Okay, this is our second video or second screencast on working out the area of a sector. So, we'll write that down. So, the area of a sector. So this is part 2. Now, if you remember from part 1, remember a sector is a portion of a circle, and think of it like a piece of pie. So there's our sector here that we can change the amount of, the fraction of the circle. And that's going to be really important when actually working out the area of a sector. Because from last lesson, you remember that a full circle, the area of a full circle, is going to equal pi r squared. The area of half a circle will equal a half of pi r squared, which is a half times pi r squared. And a quarter of a circle, the area is going to be 1/4 of pi r squared, or 1/4 times pi r squared. And if we wanted to work out, for example, 1/7 of a circle, the area of 1/7 of a circle, it would be, the formula would be 1/7 times pi r squared, or pi r squared divided by 7. This would be pi r squared divided by 4. Pi r squared divided by 2. And so the fraction, if we know the fraction of the sector, the fraction of the circle I should say, that we wish to work out the area of, that makes it really easy to work out the area, because all we do, we multiply the fraction, this fraction, by the area of the full circle. So for a quarter of a circle, you would simply multiply the fraction of 1/4 by the area of a circle. Or in other words, you would just go pi r squared and you divide it by 4. And this would equal pi r squared divided by 7. Okay, so we need to know the fraction of the circle before we can work out the area of that sector. Well, let's have a closer look at this. Because this angle in here, this angle is really, really important. Because if we know this angle, we can work out precisely the area of any sector. And I'll show you what I mean. The one thing we need to remember, that in a full circle, there are 300, we probably won't get there, 360, oh there it is, 360 degrees in a full circle. So every circle contains 360 degrees. So we'll just write that down because that's really important to remember. So a full circle contains, oops, my writing's getting a bit shoddy there. Contains 360 degrees. And I'm sure you've known that from your past year's maths. Okay, let's see if we can use this idea. Now, let's have a look at our fractions again. Let's look at quarter of a circle. Quarter of a circle, there it is. Oops, not quite. There's quarter of a circle there. Now, look at the angle inside. The angle in here is 90 degrees. 90 out of a possible how many? A possible 360. So, if a full circle contains 360, then 360 degrees, then we've got 90 of those degrees in our sector. So, quarter of a circle would be the same. A quarter of a circle is the same as 90 degrees over 360. And if you Simplify that down, 90 divided by 360 equals a quarter. Let's go around to half a circle, which is 180 degrees. So half a circle, which is a semicircle, would contain 180 degrees out of a possible 360. So it's 180 divided by 360. So the fraction of the circle we've got, in this case it's a half, it's the number of degrees in here divided by 360. Let's look at 3/4 of a circle. So there's 3/4 of a circle. And 3/4 of a circle would be 270 out of a possible full 360 degrees. So that would be 270 degrees out of a possible 360. And if we go around all the way to 360, like that, that means we've got a full circle. So one whole circle is 1 over 1, which is the same as 360 degrees out of a possible 360 degrees, which is 1. So this angle in here, this central angle, is the key to working out what fraction of the circle we've got. So I'm now going to clear this section here, and if you want to pause the video now to make sure you've copied down those notes, please do so now. Okay, I'm now going to clear this section and we're going to finalise our lesson. So hopefully you can see, what if I wanted to work out the area of that sector, or that sector, or that sector? Well, the thing that makes it easy for us to work this out is we know the angle in here. We know that this is 73 degrees out of a possible 360. And so we know that the fraction of the circle we've got, in this case, it would be 73 degrees out of a possible 360. And guess what? That is a fraction. 73 3/60ths is that fraction of the full circle. So if you remember, let's go back to our area of a sector. The area of a sector of half a circle, let's say, equals the fraction of the circle we've got, which in this case is a half, times pi r squared. So that's how we'd work out the area of half a circle. Well, in this case, what have we got? We haven't got half a circle. We haven't even got quarter of a circle. We've got a bit less than quarter of a circle. In fact, it's 73 3/60ths of a circle. And so to work out the area of this sector, and let's say that the radius is 10 centimetres. So from there to there is 10 centimetres. So that's the angle. That's the angle described by the sector, or the fraction of the sector actually. That's the fraction of the sector we've got. And the radius is 10 centimetres. So, if we want to work out the area of this sector here, it will be the fraction of the sector multiplied by pi r squared. So remember this, if we want to work at half a circle, the area of half a circle would be the fraction of the sector times pi r squared. If it was a quarter of a circle, it would be the fraction of the sector, which is 1/4, times pi r squared. Well, in this case, the fraction of the sector we've got is this. It is 73 over 360 times pi r squared. And in this case, r is 10 centimetres. So the area of this sector with a radius of 10 centimetres will be 73 divided by 360 multiplied by 3.14 multiplied by the radius squared, which is 10 squared. So if we now work that out, that will be 73 times 3.14 times 100, 10 squared is 100, divided by 360, and that will equal 63.67. 63.67 centimetres squared, because we're talking about area. Okay, so let's do another example. So I'll pause this if you wish to copy those notes down, and then I'll clear it and we'll do another example. Okay, let's say this time, in our next example, we've now got a sector like this. And we want to work out the area of this sector. So the area of this sector is going to be the fraction of the sector we've got. Now let's look at the fraction. Out of a possible 360 degrees, we've got 295 of those degrees. So the area is going to be the fraction of the sector. It's the fraction of the sector times pi r squared, which equals, in this case, 295. So the fraction we've got is 295 degrees out of a possible 360 times pi, or we haven't given us a radius. Okay, well, let's say the radius is the same as last time. Let's say the radius is 10 centimetres. So radius is 10 centimetres. So it's going to be pi times 10 squared. So that will equal, if we work this out, it will be 295 times 3.14, that's the value of pi, times 10 squared, which is 100, divided by 360. So that will be 295 times 3.14 times 100, which equals 92,630 divided by 360. And that equals 257.3 centimetres squared. Okay, we'll do one final example and then that will conclude our lesson. So if you need to pause this to copy this down, please do so. Okay, well, we've done a couple of examples now, so we can probably come up with a general formula now. The area of any sector, to work out the area of any sector. And this is the formula that you will now use, because hopefully you can now see where the formulas come from. The area of a sector is really easy. It equals, it's the angle of the sector we've got, this angle here, this angle in purple, it's that angle divided by 360 times pi r squared. And the bigger that angle, the more of the circle we've got. Therefore, the more the area we've got. The smaller that angle, the smaller the sector, and the less area we've got. So the area of a sector is going to be that area in that angle in there. So it's the angle of the sector, and we'll call that theta. We're going to call that angle theta. Theta degrees. So that angle, in this case it's 40 degrees in this example, is theta. That's a Greek letter theta, which stands for angle. Divided by 360, which is the total number of degrees in a full circle, times the area of the circle, which is pi r squared. And so one final example, let's swing this around to there. And let's say that our radius here is 12 metres. So we've got a radius of 12, and the fraction of the circle we've got is 333 degrees out of a possible 360. So if the radius equals 12 metres, and if the angle of the sector is 333 degrees, so theta is 333 degrees, let's work out the area. Now, whenever you've got a sector problem like this where they've given you the area, I want you to write that angle, they've given you the angle, I want you to write that angle down, and we call it theta. So you write down the value of theta, and you write down the radius of the circle. Then to work out the area, we just substitute these two values into our formula. Now, substitution is something we've done a fair bit of in the past, and now you can start to see, hopefully, why we need to learn about it, because now we can really do some powerful mathematics. Okay, so the area of this sector is going to equal theta, which is 333 degrees, divided by 360 times pi r squared. But r is 12, isn't it? So it's going to equal 333 divided by 360 times 3.14, that's our value of pi again, or our approximation of pi, times r squared. Well, r is 12, so it'll be times 12 squared. Move that out of the way. So that will then finally equal, doing our top line, or actually I'll do it like this first, so it'll be 333 times 3.14 times 12 squared. Well, 12 squared is 144. And all of that is going to be divided by 360. And if we work that out, we've got 333 times 3.14 times 144 divided by 360, and that equals 418.25. 418.25. And once again, well, actually not once again, this time we're measuring in metres, so our units will be in metres squared. So that's how we work out the area of any fraction of a circle that we want, any sector that we want. Remember, a sector is a fraction of a circle, a part of a circle. Okay, that concludes our lesson on sectors.